because
I'm not looking sad anymore with this voice. You.
because there's so few people in the room.
Yeah. Okay, fair enough. But it's not the quantity, it's the quality. It's really special. Oh.
Did you just ask Warren to leave?
I should, right?
All right, how are we doing for online?
Yeah, so we have a few people online, and I'll take this opportunity to remind people to please, even if you're in the room, please do join the Meet Echo tool. We will be using that for the queue exclusively. Okay, so I think that we're about ready to get going. Although, as I said before, we are looking for a note taker. So somebody kindly volunteer before I volunteer somebody. It's a little bit hard to ask for volunteers when most of the people in the room are here to actually present something. So anyone? I'm sliding a little lower under the desk.
Thank you, Eric. No. That was
Dimitri, are you in danger of volunteering?
I could. I don't know if my...
You just take the
I have a question. That's going to be the
I just don't know what it entails. Do I record it as my own and then I
We can do it in the if you go to the full tool, you can get to the
I can show.
okay, thanks.
I can show that.
Yeah.
Different people take different amounts of notes. Some people are just like action items. Some
Yeah.
people take...
And the action items are really the most important bits, and everything else we can figure out from. Great.
And of course, other people can also help contribute.
Yes, because it is a collective note-taking tool. But thank you very much, Dimitri. Okay, I have a clicker. So welcome to the IETF 122 MOPS meeting, Media Operations. My name is Leslie Daigle. I'm co-chair with Kyle Rose, who is available online somewhere. And Glenn Dean is our technical advisor. Here's Kyle. I'm sure he's waving. There he is, waving. Probably has a cat too, so I'll just be deeply envious of that. Okay. Please note well, this is an IETF meeting, and there are requirements for participation in terms of code of conduct and IPR. Please take a moment to internalize the material on this slide. And please note really well about the code of conduct and expected behavior while you're participating in IETF work. Okay, some meeting tips for this meeting. As I said, please do make sure to sign in to the session using the on-site tool or the full tool. If you use the full tool, please make sure, particularly in the room, to mute your mic and video. And yeah, as I said, we will be using the queue, the Meet Echo queue, exclusively for comments. Some resources in case you haven't yet found them for the agenda and how to address technical assistance requirements. Okay, at last, an agenda. I think every time the font gets a little smaller, and I think I'm going to have words with Greg Wood about the fact that you can't actually make sub-bullets. So grumble, grumble. Yeah. Really. I could go on for the entire meeting session about what I think about templates, but we'll save you from that. So now that you've had a chance to have a look at the agenda again, does anybody have any bashes to the agenda? Okay. Not hearing any bashes to the agenda. The chair update on the status of our recent documents is that we have had 2, not 1, but 2 RFCs actually published from our approved work since our last meeting. The AR document was published on December 28th of last year, and the Treaty N work was published on January 17th. So a round of applause for our judges. And with that, we can switch to the current working group document, which is the network overlays impacts. Sanjay, I think that's you. Okay. And I think Kyle is going to change the slide deck.
Oh, the click doesn't work?
It's not a unified slide deck. Good.
All right, we're good. Oh, so, hello, my name is Sanjay Mishra from Verizon, and my co-collaborator, Glenn Dean, is right there. We're going to talk about network overlay and impacts to streaming. Next slide, see if this works. Oh, it works. Okay, so in time and space, where we are. So we got the adopted done, and we submitted version 0.0, and then voila, version 0.1 was submitted just before the deadline of March, whatever, 5th.
It wasn't the last day. It was like at least a day or two before the deadline.
Wow.
Thank God for the deadlines. Otherwise, what would happen? So yeah, so that was submitted, version 0.1, and then we got some comments back already. So thank you, Jay Robertson, who sent us some comments, and he was nice enough to put that in the PR. So makes it easy if we like his changes, that is. But thank you, Jay. But we definitely need reviewers. We need more review. And as you will see, you may have comments as I walk through the document, and then some of the sections where we have identified issues. So we want to go through those, and hopefully we can make that interactive so that we can get some feedback here. This is, just bear with me. This is, you've heard this, and this is like preaching to the choir, evolution of viewing from broadcast to streaming. But I think it is important, because why we got to this document is because of really of this. And there's a sea change from where we were in terms of the broadcast to streaming. So obviously everything was broadcast, everything is streaming. Broadcast is just kind of hanging somewhere off of somewhere in between. But the streaming is the method of preference of viewers. We've got billion viewers, each day that are viewing content from one way or the other, short form, long form, etc. And what comes with streaming is that the viewers also expect a lot of different things from the network to provide to them. They want low latency. They want to watch live sports, and as you know, more live events and live sporting events are streamed today, and so the expectation is that it needs to support live events and with ultra low latency. Network providers also have a unique challenge to support grandma in the house who does not want to change her set-top box that she had, or whatever the dongles that's running on their home TV. So we've got myriad of devices that have to be supported. And that actually brings its unique challenges that we see in our network day in and day out. Obviously, on the other end of the spectrum is you've got 4K and 8K, smart TVs, and then you have different operating system on those TVs. And believe it or not, they all don't behave the same way. So if you think your streaming is working on Ultra HD on Samsung, it might not be working well on LG because of some unique thing that they have put in their system. So these are the kinds of things you're dealing with daily. So so basically these are all the challenges that typically the streaming platform has. And because streaming is the predominant choice of viewing today, the network service providers have done a significant amount of work in terms of putting the right platform together that can help identify what kind of traffic it is, so that they can appropriately allocate the bandwidth and whatever the latency treatment that it needs. So a lot of investment has gone through that. So it's important that I at least brought to your attention here, because that really is kind of what leads us into why this draft. So on top of the existing network that I just talked about, where we are dealing with devices, dealing with ultra low latency, dealing with streaming, and then what we are seeing in our network is that on top of that native network, you've got a set of functions that overlay on top of that network, and those functions can be doing multiple different things. They could be so what we call them collectively as those functions as network overlays, and in this draft, what we mean by that is that the network overlays are something that make changes to network policies. This could be number of things that can be changing. You could have routing changes, you could have DNS resolvers, you can have IP address assignment changes, and these are all for the right reason intended to enhance privacy, which is good thing. But these are also causing operational issues for the streaming video platform, and some of those policy changes specifically, such as IP assignments, DNS resolvers, routing changes, etc. So I've got a few slides here that will just give an example of what that actually means in terms of changed policies. So you could have alternate network policies that are on top of the underlying native network. Routing changes, we have seen examples of that. Basically, the ingress and the egress path would change. There's also protocol-specific routing changes that happens. I have a slide actually that talks more about that example. The next slide probably. There are DNS changes. Some of it is done by the network policies, or some of it is done by the users themselves. And we see some issues based on that. I know certain services rely on eDNS 0, and when a user changes to a public DNS resolver and they go with, let's say, 1.1.1.1.1 Cloudflare's public DNS, that may not support eDNS 0. So if you were relying on watching TV that will deliver you on your handset on your home Wi-Fi, you may not actually get that content from the cache which was designated to serve that user from that location. So those are the type of changes that just manifest themselves quickly. And the DNS changes also with the DNS 53 moving into DOE and other variations of it. Other changes, IPv4 to IPv6 and otherwise. So these are the kinds of changes that we see in the network that have impacts that are sort of not planned for and unexpected, and that leads into a lot of different issues. It leads to issues to the users calling and complaining about it. Technicians on the network side are having a hard time trying to figure out why they can't watch TV, because they have the app. They are in my case, in Verizon's Fios TV app running on their home phone. Why is it not working? And it turns out that they were using a DNS resolver that didn't have eDNS 0, and that put them somewhere else, and they got blocked. So let's talk about some more examples. So this is the example of that the different policies have different behavior of how the protocol routes. And the one that I wanted to highlight here is that the preferred path would be if a home device is watching content at home, and we want them to make sure that they're getting content from the server that has been deployed in the network specifically for that purpose, so that we can cache and serve the content. And we want the path that you're seeing that is shown here by the yellow color. We want to take that, and sometimes it does take, but there are other times that the path would be on the blue side, which may be right for some other functions, but may not be right for HTTP traffic, which they may be going through multiple hops. So let's see, there's another example here. Yeah, this is my favorite. So this we have seen in our network that the caches, there were a number of different reasons, and part of that was changes on the DNS side, changes on the IP address. So because of that, what happens is that the preferred path would have been the blue path for getting to the edge CDN cache, but in fact, as you see in the red, is essentially that user is traversing and eventually getting content from the not the most optimal CDN. So they're still able to get the content, but they're not getting it. They're seeing buffering, or they're seeing some other issues as well. So that's really is one of the challenges that we see in the network with some of the DNS policy changes, as an example. So given some of that background, the next few slides that we have here talks about some of the impacts that we have identified. One thing I didn't call out is that the intent of the document is to capture what are all the issues that operationally one is seeing. So we have a list of issues that we have captured, but obviously they are probably not exhaustive. So this would be the perfect place for us to walk through those and get your input as well. Okay, so this is right off the draft. So the one that I want to call your attention to is the section 2.2. Number of policy changes that we identify that have some impact one way or the other. And again, this may not be exhaustive, so please let us know that if we are missing something. But at the same time, as I go through it, I would like to get some, if you have questions and thoughts, obviously stop me. So just kind of walking through each of these sections, and I thought, Glenn and I were working on this yesterday, and we thought that it would be useful to sort of share what we have in the document and then outline and see what kind of feedback and questions people may have. So starting with the IP address changes, one of the effect is that the network overlays often change the source IP address of connection, and that really would translate into your local cache not understanding that IP address, and it'll block it. It'll say, oh, well, actually my internet gateway router will block it because it's not an IP address that is owned by the AS701, and basically that user would probably go out to a different cache to get the content from. Glenn.
See, I follow the rules. So part of the question Sanjay is asking here is that we have in the document captured, we know there's an issue, there's a set of issues here. We're going to go through them one by one. It would be very helpful to us as the editors of this document to get specific examples that people could quote. And we're not looking for this platform has this problem in this situation. We're not trying to call anybody out here. We're trying to create the detail around documenting these aspects so that ultimately, as a problem statement, people can read this and really understand how it would impact them. Because in conversations with a lot of people, what we've pulled out is that very often people read this and go, oh, that's terrible, you have this problem. And they don't realize that they have this problem. And as they dig through it, and as you explain to them more, they often go, oh, maybe I do have this problem and I'm unaware of it. Because often if you're not looking for it in your logs, you're not looking for your load balancing information, these policy changes aren't in your face that they're causing you problems. But when you start looking for them, you realize they do have impacts to me operationally that I'm maybe not aware of. And so what we're sort of looking for is help here in detailing that. And so the exercise is a little bit explaining what we are seeing, asking the MOPS community to think, okay, how does that affect me? Where might I see this in my environment? And how can I better describe it so that we can capture that problem statement in this collection? And also what we've missed. At the very end, Sanjay will have one that says, like, did we miss something? Because we know these are problems, but they're problems that are a little insidious and that they hide until you run into them. And sometimes you don't even realize that that's the problem you ran into, such as these protocol changes, because this is very subtle. If you have a web server that, or a CDN cache that will talk HTTP 2 and 3, and you get an auto upgrade to 3, that may not directly have an in-your-face issue, but it may be causing you some other problems. Such as if you have tooling that is doing data collection and telemetry on HTTP2 sessions, and you get a bunch of upgrades to 3, they drop off that, but you may not realize they dropped off. That's a sort of an example of the kind of stuff we're looking for to illustrate in here. So don't be shy. Either get up to the microphone here today or go to the document. It's in the working group thing, and we have the GitHub repo, and you can put in issues there or pull requests to give us that additional details, sort of what we're asking here.
So Mary is in the queue, and I assume you're happy to take comments as we go?
Oh, yes, yes, please, yes. Want to make this interactive as we can.
Yeah, Mary Kulevin Erickson. So I just got poked by something you just said. It's like applications don't expect one or the other protocol. Actually, I think applications shouldn't expect any protocols. They should expect some kind of like service features or whatever. But one thing we've been very hard trying to do is make applications independent of protocol details. So you can actually evolve your protocols and make them more secure, make them better and whatever. And usually it should be better for the application, but maybe there are cases where something is unexpected. But actually kind of providing some guidance about how you can design your application to make it more independent of very specific protocol features, I think that would be something really, really useful.
That's a really good comment, and let me explain that. Part of the intention here is this is capturing the problem statement, and it isn't the intention that the problem statement only applies to protocols or these overlays and how they operate. The follow-on will be a document talking about mitigations and things like design your application such that these situations don't impact it can in fact be a very well-documented mitigation that we will include in that follow-on document. So step 1 is document the problems, and then step 2 is sort of document around them. I will say that today, from a video application standpoint, we populate the manifests with URLs, which include a protocol declaration. And the workflows for that video delivery very often do depend upon and being aware of if you're using 2 or 3. And one of the other changes we deal with sometimes is upgraded encryption. And that's because in certain workflows, there are situations where you are doing inspection of the content or the traffic, not from a privacy invading standpoint, but literally from a classification standpoint. So you can say, this is content that is better delivered by this CDN versus that other CDN cache. And these are network level tools we're doing for management. This upgraded one is the tricky one because one of the examples that it encounters is where we have field people trying to do problem determination. And you say, well, do this, let's see if that works. You run this test. If you don't know that you have different behaviors on some networks of HTTP2 versus 3, that can make problem determination really tricky because you could have the help desk running probes on TCP, and it turns out that the actual problem is that you have somewhere in the network a quick block. We've seen that in some territories that quick is not a widely reliable protocol in some situations. You're a quick expert, so you probably see this as well. And that makes our support teams go, I don't know what to do. And so we're trying to figure out what to document here in this description and then get those mitigations to help people figure out how you either design better workflows or better tooling or whatever. Does that make sense? Is that an approach?
Yes, and I probably should read the document a little bit better, but I'm a little bit afraid of, I totally understand what you want to say, and I think people need to be aware of what can happen, what can break or whatever, but like putting this as a problem in itself seems a little bit wrong. It seems like, because problem somehow implies that somebody broke something, but I think this is just like something we have to cope with forever, that like things are changing, we have to adapt, right?
And I think in the current version and in prior versions, we try to be very careful to say that this is not meant to be a blame pointing finger, like this is your problem, you caused me grief. What we really do see this is it's sort of a consequence that came out of, in parallel, while video was exploding and all these video ecosystems were being developed, the IETF was also putting a lot of energy into developing privacy enhancement protocols that are largely represented by these things. And it's when the two things came into contact operationally that we started getting the friction. And so we call it problem documents because we have this concept, but really what we're trying to capture is the friction points, describe them well that's causing operational issues. So then we then know when you create the mitigations document, what do we write there? What operational issues do we need to address and document? Because I'll tell you, one of the big things we often see as a problem is that, and I'll use the word problem because from an operations standpoint, we call it a problem, is where the application in its environment expects one thing to happen and something very different happens without notification to the application. And in particular, sometimes in situations where the applications are doing test probes to say, I'm going to do this, what's my result going to be? But he gets a different behavior than what is actually happens when he actually does the thing. A classic example is I'm going to do like a test load of some content, and he does one URL and it goes through one path, and he does another URL and it goes through a different path, and your test doesn't work. And trying to understand that and capture that is part of the goal here.
Yes, I think the point I'm trying to make is that this is not like a unique point in time where we have this friction. I think this will go on because we keep evolving and we keep evolving very quickly. So we kind of have to change our way of working, our assumptions, and make this work in future more and more. And I think what you also said is basically there's a little bit of an interface problem. There's a tussle here between exposing a lot of details about what you're doing on the transport layer to the application, and then the application might use this information and might bind itself to very specific things, or exposing less and therefore having more flexibility in the transport layer to try to optimize there, right? So this is a general tussle we have and we will have in future, and we just need to find the right operation point somewhere there.
Yeah, so I think I'm going to use that as an opportunity to point out that this is documenting operational realities of the protocols and their use. So you're right that it's not a unique point in time, but hopefully this will help capture some of what is out in the wild, which can inform also both. It can go both ways. It can be, use the applications and protocols correctly. Here's some guidance, and it can also be if that's what you're really trying to do, then maybe some of these things need to be engineered a little differently. So documenting the current reality, I think, is the point.
Yeah, and part of it is making things deterministic is what we've realized is important. And the reason why this has become sort of a friction point and why we started the document in the first place, because this work started over the Streaming Video Technology Alliance, who was talking about operational issues, is that as video expanded, like Sanjay at the first slide said, we are hitting scaling limitations where even little things that don't behave as you expect in an architectural workflow can cause some huge operational disruptions to sort through. And so we're trying to sort of document that so that we have a bi-directional conversation between the designers of these overlay protocol changing in situations and operational video applications as well. So we can understand each other and work together cooperatively.
So then one last question, hopefully. So I think documenting this is very useful. The question is it useful to have this published as RFC? Because I feel like something that is a little bit more future looking would be like the more important thing to put in an RFC.
Yeah, so I think the first step is capture what is currently reality, and then figure out where to take it from here, right? I mean, that's the important step. And I know Sanjay has 8 more points, so.
Yeah, and I'll go back, Miria, to your point that sometimes the problem is that it's not easy to decouple an application from the protocol. There are some business cases where you would want your app to be basically running HTTP because you might want to. There might be business reasons where you want to zero rate for that service, but because your app is running HTTP, it gets sort of changed into something else, and now the original purpose of the app that was zero rated is no longer zero rated because it has the whole look of it is changed because it's encapsulated into something different, has a different IP address, and it's taking a different path. And so that's one thing. And then on the business side of it, you can't zero rate it because you don't know how to zero rate it now. So that decoupling sometimes is a challenge.
Yeah. So actually, I think this is the part I would be interested in. Rather to say only what breaks, I would also be interested to understand why an application is making these assumptions and why it has these restrictions. Because I would assume if we want to have both, we want to have flexibility of protocols, then there might be a different way to also achieve these goals without binding it to like one specific protocol, hopefully.
Right. So it's an issue, right? It's a problem. We just have to figure out how to document it, and then if it's not documented, then it won't get resolved. All right. So next slide.
Go for it.
Go for it, right? So this one is sort of related again, right? This is on the routing changes. So the alternate routing paths get created, maybe because it was the DNS or it was because of the IP address got changed. But nonetheless, that will basically cause a different route to be taken, and that routing decisions then not only leads into the immediate effect is latency, but if there are issues because the content is not getting served, then it becomes an operational issues, and it is very hard for the operations to basically put their hands where to put their hands onto is to really start to figure out where the problem is. All right, so moving on to the next one. So this is going into the DNS resolver that gets changed. Some of it could be user selection themselves, that they can select public DNS resolvers, or sometimes the app itself is making the decision. The protocol is making a decision and then saying that this needs to be DNS in this one way.
Yeah, just one comment for the audience. In particular, one of the things we've come across is situations where DNS gets changed to a DNS that does not provide eDNS 0 information. And if you have an application workflow that expects to have that information to be able to make decisions, you have an operational impact that's very hard to deal with because the information vanished.
Yeah, yeah. And we have this problem. This is a very common problem. We see this, and it manifests in many different scenarios, but it's one of the very common thing. And then the technical, there's no one person sitting in a room that will say that, oh, I saw this problem yesterday, so I know how to fix it. You've got a whole, now there's working 7x24, different people, different times, different time zones, different areas. So it becomes hard to troubleshoot, and it's not very pleasant when a paying customer is complaining about, I can't use your service. All right, so moving on. Encryption policy changes. Overlays can also enforce and modify encryption policies, which can again impact the ability for applications to inspect or optimize traffic. And this again goes back into the troubleshooting bucket, because you can't see, so you can even resolve the issue.
And I'll put it equally so, it could be the removal of encryption when you're expecting it to be going through an encrypted flow and it suddenly doesn't.
Yeah, it cuts both ways, yes. All right, so 2.2.6, maybe, there it is. Traffic classification changes. Do you want to say something about that? But really, the network overlays can obscure and alter traffic classification. And then there are, again, multiple things that basically fall out of this. You are not able to prioritize traffic sometimes, or you'll see the traffic classification has changes. So some of the things that shouldn't be congested are at least on a queue that are congested. So there's a little bit of a challenge there.
Eric Ving, no hack. Is it linked to the previous point? The previous slide is about encryption and the lack of basically traffic knowledge. Is this point linked to this or to other points as well?
They're all kind of interlinked because they pop up. Again, these are policy changes. So in particular, if you have a traffic classification system active on your network flows, whether it's a mobile network, we see, because they do that on mobile networks, then this, we call this out specifically because where there are network systems, not a lot of, sorry, I'm dancing around this a little bit because there are network segments that we will never use traffic classification on. Mm-hmm. There are network segments that you may traffic classify by something as quite simple as are you L4S EC21 enabled or not enabled? And if you have flows that suddenly change things and remove something from an L4S queue, for instance, that can be bad, and it can be a traffic classification change that you didn't expect. To your point, though, are they interlinked? Yes, all these sort of points are sort of interlinked in different ways. And we called them out specifically because some people say, well, I don't do classification, but I do protocol. Other people say, well, I don't really care about the protocols, but I do have traffic classification active on my networks, in particularly mobile networks.
Okay, my main question was that, is it this problem between quote, is it only caused by encryption? But you say no, so that's
Correct.
That's not my question.
And the other place we've seen this pop up, by the way, is there's times when people have changes from TCP flows to UDP flows, and some networks do UDP differently.
Yeah. All right. So there's one of the things we've also observed in the network is that if the network provider has a downstream CDN, if the downstream CDN is basically you're expecting it to be in the flow but is not in the flow, and then it's hard to come to figure out that actually is not in the flow because something else earlier changed, which is causing the connection to bypass the local caches, but actually go out to different CDN, which is not in your network. So this is the issue when you have an IP address change. So if I was running on A701 IP, but actually that got changed to something different, which is not in my network, so it's definitely not going to get served through the local caches because it will never go beyond the local routers. And in this case, when you're trying to troubleshoot, your starting point is difficult to know that it is actually the other CDN which is causing the problem and it's not your CDN. So if that makes sense.
And it all comes back to the theme that it's knowing deterministically what's going to happen. And when that changes and you can't determine and you can't predict, that's where the real problems seem to occur. Yeah. Okay.
All right, so let's see what else we have. Multipath changes. Some overlays are using multipath technologies, and that is just very added complexity in terms of, again, troubleshooting and performance. It's hard to optimize the performance because, again, it's taking the path that you never intended, initially for it to take. So this becomes a little bit hard to troubleshoot. And let's see, what's the next one? So there are probably other changes that go beyond of what we have listed and seen. So some of these are probably not known. But we know that there are other types of changes as we learn over, how the network is behaving. So we don't know what we don't know yet is what we're trying to say here. And so this is the one that I was talking earlier that we probably have not listed everything that is causing the operational issues. So look to MOPS to give us some feedback on anything that we have missed, or there are more thoughts and questions we want to have on the previous, 8 or 9 of those points that we covered. So definitely want to engage in conversation in the mailing list or here. In terms of what we have, is that really not an issue or it is an issue? You agree, and that would be a good start. And then anything that we miss, we definitely want to hear.
In particular, this is a MOPS document. This isn't a Glenn or a Sanjay document. We're the editors, and this is our document. So help us out by fleshing it out for the material that we want to represent and capture here.
Yeah.
We know we have problems. We've had a lot of people raise their hands and say we have problems.
Yeah.
So let's capture them.
So then to round off the conversation here, so moving the draft forward towards the working group last call, how do we get there? So one, as we said, this is the intent of this document is to capture operational challenges. So that's one, and we're not done with that yet. We want MOPS to provide us feedback on that part. But we're hoping that as we move forward here from 122, and we definitely hope to have multiple changes and reviews coming in. We already have one from Jay, as I said, but we're looking for more robust critique of the document in terms of qualitative as to what use cases we have identified. Want to get some good feedback on that. Add other use cases that we have missed. So we want to do that between now and 123. And then hopefully if we get to that goal in 123, then what we think might be a good idea is to see if we are at a point in 124 to call for working group last call. And if so, that the next step really would be that we want to propose a different document that would be basically trying to mitigate on some of the challenges that we would have covered in the previous document. You want to add anything, Glenn?
Just that one of the challenges we face here is that there are a lot of video engineers, CDN engineers, who have been very clever over the last decade. And they put in place a lot of assumptions in their architectures. And some of the architectures are unique and creative, very creative sometimes. And so trying to take that and generalize it so we're not calling out any particular platform, any particular architecture decision has been a bit of a challenge for us. And it's part of the reason why we get it that people want to see more detail in some of the sections. We're trying to figure out how to put that detail in without picking on anybody in particular. We don't want to call anybody out. But we want to capture the general case. And that's hard.
Yeah. Go ahead, Eric.
Yeah. So Eric, this time as a responsibility, what I strongly suggest, and I was writing an email to the authors on this and the chair, that around IETF 123, to basically send this draft and try to have 2-3 minutes to present it at, for instance, I know at Scone, right? And as well as maybe at Mask and something, right? To get early review there.
Okay,
I think
a good
that's
idea.
important. And that's all. I will send you anyway.
Thank you. Oh, there it is. Thank you.
We're polite if nothing else.
Yeah.
All right. Anything else? Then I'll urge everybody to read through the document and review it with those points in mind. And then the authors have a timeline, but I think that there's still plenty of time to review it in the context of the working group and decide, to Miria's earlier point, what the next step is, whether it's mitigations or future looking or other framing. All right. Thank you, Sanjay and Glenn.
Thank you.
Okay, next up we have everything else going on in the IETF. So Padma, if you would be willing to tell us about TipTop.
Hey, good morning, everyone. Whoops. Either too far. All right. Do you guys hear me? Right? Okay, great. So good morning, everyone. I'm Padma Piliasno, and I'm very excited to introduce this new working group called TipTop. So what does TipTop stands for? It's about taking IP to other planets. And what we're really looking at is interplanetary networking, IP networking. So as you can imagine, the first thing that comes to our mind is that it's going to be very long. The delays are going to be very long. But I wanted to show here the order of magnitude of how much delays. It's not in seconds, but it's in minutes. It can, between Earth and Mars, it can be anywhere between 4 minutes to 24 minutes. So there's also a variability there. So what TipTop is trying to do is to adapt IP networking to work in those cases. So, and what we really want is not to create a new architecture. So how is this environment really different? So first of all, we talked about the delay, but there's also something which is frequent and long disruptions in the nominal case, which is typically not what we see on terrestrial networks. And of course, this happens mostly because of orbital dynamics. The satellite may find itself on the other side of the planet or any celestial body that goes in front of it. And of course, in those situations, we don't have alternate path. And another factor is about the links. The links are very different from what we see on the terrestrial links. They can be low bandwidth, but they also have asymmetric links. And then there are two factors that really is dependent on the satellite itself. Number one, it can have low computing power. And the second one is that its energy consumption and how it recharges. It can be anything from, yes, we actually can talk to the satellite, it is in line of sight, but it doesn't have enough power and it has to reorient itself depending on whether the panels can be reoriented or the satellite itself has to go into a reorientation mode to catch more solar to recharge the panels. So however, with all these difficulties, one thing that's really great is that we actually can track bodies in space and we track objects. So we can pretty accurately say when we are going to have an opportunity window to talk to any of those satellites and plan for it. Now, we have to make IP protocols handle those disruptions and be within those constraints. So this is a little bit what we're working on. And we can ask the question, why now? So there's a big change in the space industry. There's more and more commercial missions coming out in the space arena. And there's a real need for interoperability, scalability, resiliency of the network, which is very different from what we've seen previously in government-led missions. So, like I said, the focus is going to be on adapting the protocol stack, parameters mostly, and what we really want is to try to reuse a maximum existing protocols. Now, Tip-Top Working Group will have to work, of course, very closely, coordinate with all these other working groups. The ones that come to mind is not exhaustive, is time variant routing, Quick, TLS, DNS ops, DTN, and I'm sure a bunch of others that we're not thinking yet, to make sure that we are aligned and that we can advance the recommended work. So where do we start in all that? Currently, the very first step was to identify what are the use cases we want to be in scope and which ones are not. Look at their characteristics and requirements and actually make sure that the IP architecture identify where we need to those changes. So not really changes, but adaptations rather is a better word. Another aspect we're looking at is the Quick protocol and how we can actually change the parameters so that it can tolerate those very long delay networks. So that's going to be a change on their base parameters. And last is we have to look at DNS, how it is going to work, especially if we have things like very futuristic in the future, like we'll have a cluster on the moon, another cluster on some other place. We're going to have orbital satellites that are relays. So we need to think a little bit how we're going to go about this. So if what I said here sounds exciting, we have our very first meeting that's going to be on Thursday, 20th at 3 o'clock in Salatai Ballroom. And our mailing list is deepspace@ietf.org. And really, we'd like to have more people. And I think there's a lot of input that we can get from other folks that have seen other things. Like earlier, Eric was saying, the slide number 7, that makes a big difference for us as well.
Right.
So we're coming with completely new set of requirements. And I think the more people participate in it, the better we're going to be. So anyway, see you there.
Quick question. So at the recent SVTA meeting in Tucson, NASA came to the meeting and did a whole presentation on, I guess they have a plan. They're going to live stream from the moon. Are they working with you already, or is that an independent effort?
No, actually, a lot of them have actually proprietary, sometimes permission. And as far as I know, they're not necessarily using IP. So that's the big difference here. So it's a different effort.
Okay, thanks.
Thank you. And then next we have an update from the SCONBOF from Ken.
Good morning, everyone.
You're good. We can hear you.
Yeah. Okay. Great. Yeah. So it's great pleasure to meet you guys in Thailand, Asia this time. And my name is Qing Wu. And so I want to take this opportunity, give a quick update of what the SCON working group is doing since the last IETF meeting. So thanks, this year for kind invitation. Actually, for people who haven't followed this SCON working group, actually, probably actually if you follow the earlier activity of the SCON effort, actually it used to be named as SET-CDN, and that means secure accelerator in the network device, network device in the networker. Later we changed the name into SCON Pro and SCON. The SCON actually represent standard communication of network elements. So whatever name it is selected, I think the overall goal is really encourage more collaboration between the network operator and application and content provider, and make them to work together to really improve the user experience of the existing service offering or new service offering. So this is a really good opportunity. So why SCON working group? Actually, take actually streaming application as example. You can see in the left figure, we have a client and a server. They can communicate with each other. They support various different bitrate encoding, and actually streaming really allows server to deliver, for example, the video contents to the client endpoint, and to actually instead of downloading overall, for example, video stream contents, the files, you can break it down into the a set of the chunks or segment. In order to improve the user experience of HTTP service, you may actually client need to estimate network capacity or network throughput, but currently client lack a good collaboration with the network elements, so they only can actually to decide the for example resolution of the next segment based on estimate network capacity or network throughput. So this causes better user experience. In some cases, worst cases, it may drop the packets. So what the SCON working proposed to do is introduce a network element in between, and really allow the network element to expose the throughput advice to the client endpoint. So this can be consumed by the client endpoint about these applications. They can to decide the resolution of each segment, based on the real measured the throughput advice. So this can greatly improve the user experience for HTTP service. And so what is the current status of SCON working group? And we actually have first the former working group meeting in Dublin and in IETF 121 actually, and we actually review 3 protocol proposal, and you can see in the middle actually we have a chain, we have a quick SCON quick proposal, we also have mask extension proposal, and try to better understand the similarity and key difference of these 3 key protocol proposal. And in addition, actually we actually invite a talk to team explore some related work, for example, to discovery the network rate limit policies, and which is ultimate mechanism for collaboration between the application and networker, and so based on the previous Dublin meeting discussion, we actually agreed to set up 2 work stream, and the first is protocol framing. The second work stream is focused on semantic content actually. So after double meeting, actually we successfully scheduled 2 interim meetings. Mostly focused on protocol development and try to narrow down the scope, make very different protocol proposal problems to work together to converge on the single merged protocol proposal. And in addition, actually, we also invited some talker from operator like Sanjay and from Dan, from the operator community, and to explore some of SCOAN use cases, and also to discuss one proposal like a video session data rate. Actually, this from Dan actually from AT&T, and they really actually try to explore how we can measure this data rate, and reach agreement between endpoint side and also network element side. And so actually the outcome of these 2 interim meeting is finally actually we make a chain problems and also SCOAN quick protocol problems to work together. So as a working group chair, actually we allocated the working GitHub for this merge protocol proposal. We make them to work together, and just before this meeting, they post a new individual draft. So the target for this IETF 122 actually is reach consensus for this merge protocol proposal to really want to see this as a baseline, for working adoption, and so we can keep on spinning on this protocol to further, improve, and also maybe in the future we will explore some, like a MOPS extension. And in addition, we also invite, some other, topic, for example, actually, SCOAN mobile network use cases from Sanjay. Actually, he already presented in the interim meeting. We want to discuss this again. And another way is about SCOAN taxonomy, actually more related to sorting policies, and so we'll investigate this. So we hopefully this could be input for one of the SCOAN work item we call the applicability and managing applicability. And so that's the current status. So this is the overview of the merge protocol proposal we call the Chuang protocols, and you can see in the left figure, actually really we have a Chuang protocol communication. This really can be used between either quick sender and the network element, or between the network element and a quick receiver. So this Chuang protocol message will be initiated by the quick sender. This will be intercepted by the network element, so they can insert additional network property, for example, rate and advice, and so this can be consumed by the quick receiver. And in the right, you can see the current, the format of the Chuang protocol, and you can see what it look like. But still, we need more discussion on the the size and the format of these Chuang protocols, and hopefully we can reach agreement on this open issue.
I'm starting to feel like I'm becoming the Ecker for video, and that I have a question on every slide. I can talk faster if you like. I'm not sure you can do a full Ecker, but I can try. One of the questions I have for SCOAN and for this workflow is the assumption in the diagram is that the network remains stable, meaning that it's the same network you're talking to all the time. One of the things that has come up in some discussions in my world is if you're on like an iPhone or a tablet, and that iPhone or tablet is switching networks under the covers without necessarily informing the application, how does SCOAN envision communicating the different SCOAN communicated properties of, say, a mobile network that you have this minute versus the Wi-Fi network that you have 2 minutes from now, and then maybe 3 minutes from now I'm onto a different network? Is there a trigger mechanism that informs the application? The network has changed, new rules apply. How's that envisioned? Do you have a sense of how, does my description of the problem make sense? First question. And then 2, if it does, how do you envision solving that?
Yeah, that's a good question. Actually, I haven't finished my presentation because I want to, cover this maybe related to your question. And let me, introduce this. So really, yes, for collaboration between the, application and network, actually we have a bunch of related worker, and currently we, for example, we have two work stream. Actually, one focused on semantic contents. They only limit to throughput guidance. So these very limited network properties, but we can envision actually based on the iterative development, we based on the use case you described, actually we can have more network property maybe can be exposed by the network element to the application on the client endpoint. Also, we expect for client endpoint, maybe they need to for example, they want to confirm for the receiver this throughput advice, and also they may need to indicate their capability to the network elements. So this additional piece we may consider if we have the baseline. So I think based on your described use case, we think we can further explore how it can work. But at this stage, we really want to have baseline document lightweight and focus on minimal set of the application, and not want to more generic to cover all the application.
Okay.
Yeah. So
it does seem that there's similarities between the work Sanjay has presented and some of your requirements.
Right. So really want to encourage more contribution from network operator community and also application content provider community. They can contribute their ideas, their input to help us better understanding how SCORM can be used, and how we can leverage this SCORM. I see 3GPP already explore how SCORM can be used and integrate into UPF architecture. So this is something we may consider in the future. We may exchange with 3GPP formally. And Eric?
Yeah, so can you come back on the couple of slide, Chin? And by the way, no head, obviously. This thrown plus quick, it assumes that the thrown packets are following the same path as the quick packet, or are they inside the quick stream? Because I mean, I don't know, quick SUDP can follow one path, is thrown SUDP a different port, it may follow up a different path, right? ECMP, for instance, or whatever, anything different devices. But that's one question. And the other question is, the network element now needs to look inside of each and every thrown packet. Is it done by hop in IPv6 or something like this? You think?
Yeah, that's a good question. Actually, we need to consider this, multipath issue, ECMP, how this, can be dealt with. And I think
no need to reply now. I'm just curious, right? So that's all.
Yeah, that's a good question. I think this has been discussed in the previous meeting before. Cover some of these open issue. We haven't get a stage to resolve all the issues. Yeah, we need to prioritize all these issues that need to be solved. Yeah, at the current stage. Yeah.
Okay, so one more question. On your previous slide, did I see that you have a mask?
Yeah.
Okay, so that would take care of some of the questions you asked, Eric, with the step-by-step, if it's a mask overlay, because they're going to have to figure out how to solve that. For which one do you honor? Do you honor the underlying network that's carrying the mask transition, or do you honor mask? That's hard. This is a very hard problem to have.
Right. We haven't get to that stage yet. Yeah, mask could be the something we should consider for the second phase. Yeah. Luis?
Yeah. Sorry for jumping late. One maybe basic question. What is the incentive of the network operator here for this? I mean, of getting the complexity of implementing this, which is basically overlay thing as Sanjay was presented before. I mean,
I think Sanjay actually gave a good example. He tried to explore how SCORM can be integrated into the UPF or 3GPP architectures. So we need to operator to use this, but we really need to make both network operator and also application content provider have mutual benefit. They can sign agreement on this. So this I think we need some operator to really to.
I agree on that, but the point is somehow that here the application is somehow transferring the complexity to the network operator. but not clear to me the purpose. Clearly is for sure the best quality and so, but what gets the operator from all of this complexity for inheriting on this? And you mentioned, for instance, the UPF. So is sufficient stay at the UPF? Would not be necessary to have the calculation up to the origin of the content of the media? I mean, somehow probably we are missing some part of the problem here.
Yeah, so that's Sandy just focus on mobile network. I think we have we have some other use cases we need to cover. I think we have work item we call the applicability and manageability. We really need more input from network operators. So I know actually Meta has some related work actually really want you guys to join together, maybe with Sanjay and someone else to contribute for this applicability and management. This really a network operator can play more role. Yeah, I think. Yeah.
Sure. Thank you.
Thank you.
So not to go into details, Sanjay Mishra. So I do encourage folks to come into this SCOAN working group where there is a proposal that basically outlines that here's the network element that can do the job. So, but I want to hear from mobile operators to see, how they see that, or is that a good idea or is that a bad idea? So I want to do that. But the presentation is meant to provide a starting point that there is an element in the network that can do that job, and also the set of requirements that are needed to do that job. So that's what that draft is. So I'm presenting it, and I want to hear from people, especially the operators as well as the network equipment vendors on the viability of that solution. Yeah,
great. So in addition, actually, we received one proposal from the Met. Actually, they try to explore the SCOAN sorter policy and evaluate the impact for this sorting. So I think this we also need to involve the network vendor. With that, actually, I think we have SCOAN meeting already have scheduled on Friday. The first session, the meeting location is Chidalada. So welcome to join this meeting. With that, I conclude my presentation. Thanks for listening.
Thanks very much. Great, thank you. So next we have the SVTA update.
I have the clicker. All right. Hey, I'm Glenn Dean. I'm going to put on my SVTA hat on for a minute. We do these updates regularly. The SVTA is an industry organization that does, well, you might guess it from the name, streaming video. And we do technology, and we're an alliance of people that do that. The SVTA is about 11 years old now, and it was created to fill a void because professional video platforms and technology partners didn't have a place to come to talk about video issues. And we provide sort of an industry perspective. In some ways, we're a little bit like NADOG. If you're familiar with NADOG, where the network operators get together to talk about networking issues, and they bring things back to groups like the IETF of what they need, and vice versa. We do the same thing at the SVTA. We work on video platform questions, and then we bring back to the IETF issues and stuff like that. Network overlay stuff that Sanjay presented started over in the SVTA as a operator's document where we described the problem space there, and we brought it here. Likewise, things we talk about here, we take back over the SVTA and bring the industry up to date on what's going on. So it's a bi-directional conversation. And usually during IETF meetings, Sanjay or myself or somebody else gives an update of what's going on between the two groups. And so that's what I'm going to do today. So who are the SVTA? It's a lot of people, and we keep getting new members. One of the big things that happened late last year was DashIF merged in with SVTA. So if you're familiar with DashIF, they're part of the family now. DashIF and SVTA are one. But we have a lot of members, including the space stuff. See, NASA's up there. NASA is one of our members, which is pretty cool. I mean, seriously. We're also a lot of brands, and these are some of the brands that are part of the SVTA family that we represent. The SVTA is roughly made up of three groups. It's content owners, content platforms, so people that do streaming, have content that want to stream. It's made up of CDN, network operators, and people like that do the work of doing the delivery and the streaming. And then it's made up of technology partners that create all the technology that goes into doing the work that the platforms do. So it's a industry organization, not just one bias. We're trying to be inclusive of everybody.
CBS might want you to use a different color for your background.
You know, you're right. I will say whoever designed logos, they made them really hard to fit onto one background color. Because even if you choose white, if you notice, white will disappear a lot, including my own company's Universal. If we choose black, ESPN goes away. We need a standards org that picks colors for logos so you can put them on backgrounds for these slides. So what does the SVTA do? This is a big one. If you talked to me 11 years ago, you said, what does the SVTA do? I'd probably say we do open caching, because the original mission of the SVTA was to take things like CDNI and build all the other pieces around it such that you could deploy it operationally as a caching strategy. Since then, boy, have we grown. We have covered things like we've done geolocation, publication standards for how you put JSON out to update your IPv6 and IPv4 geo identification information for networks. That's part of the group I chair. I chair the networking transport group over there, which is down there in the corner, which we've been doing things like working on quick POCs. And I'll show you a publication we just put out. Today, I'm going to highlight a couple things. We've talked about -IF. They're now part of the SVTA, and they're doing a lot of really great work. They publish stuff through places like Etsy, and inside some of the IETF stuff, they also do work there. So -IF is a very welcome part of the family, and we're very excited that they're doing stuff there. We're doing a segments conference. We've put on 2 of these things so far. I'll show you a slide of something coming up that really is relevant to the IETF. There's a hint. But there's 2 brand new working groups I want to draw people's attention to that are really media related and I think have connections to the IETF. One is encoding and packaging. For those who are not media people, this is the encoding and packaging is the step where you've captured something on a camera and you need to turn it into something that can be streamed. And you do the transcoding to different codec formats, but also you structure it. So if you're familiar with adaptive bitrate, where you have to put out multiple encoded bit rates that have aligned segment boundaries or aligned B-frame or I-frame boundaries, that's encoding and packaging. It's how you set it up so you can later stream it and do things like adaptive bitrate. That's a new working group we spun up. And I'm going to go into detail on the other group we've spun up called EDGE. But this is sort of the collection of groups we work on. Measurement QE has direct ties, obviously, to the IETF because it's networking. Low latency network streaming. This is live. This group used to be called live, but we realized that the use case that they were focusing on was low latency. And by low latency, this means if you look in the streaming world, really bad examples of streaming and latency, there's some platforms out there that are 30 seconds, a minute, minute and a half behind what you might get on broadcast. The goal is to get those things down to either be at the same as broadcast or if not better than broadcast. That's hard. A lot of people are there already. A lot of people are still working on it, but it's a hard problem. It's a scaling problem. And it's a protocol problem. So it has a lot of ties back here to the IETF. So anyways, let's talk about things. So Madrid. The IETF is going to Madrid. Guess what's happening the week before the IETF goes to Madrid? In the exact same hotel. The SVTA is going to Madrid. And so we are going to be in the same hotel right ahead of the IETF. Our meeting is going to run, members meeting is going to run Tuesday, Wednesday, Thursday. And on Friday, we're going to have a conference called Segments. And it's open to anybody. So you don't have to be an SVTA member to present at it, and you don't have to be an SVTA member to participate at it. So here's the rough timeline here. There is a website. If you go to Segments and you look at Madrid, you get information about it, and we are taking papers. So please submit talks. Warren, I'm not sure it is you because the picture that I see on the screen has a different hat.
Oh, strangely enough, the hats are changeable. So just so folk know, right after the IETF in Madrid is going to be IEEE. So people could come along and do this, and then IETF, and then IEEE, because, you know, spending 3 weeks in Madrid in July sounds like a great idea.
It does. It'll be a cool experience.
See what you did there.
Also, a heads up, in the fall, when the IETF goes to Montreal, which, by the way, will be sponsored by Comcast, NBC Universal will be the host. We're also going to do SVTA in Montreal the week ahead, and there will be a North American segments conference. So if you can't make it to Madrid, make it to Montreal. And they'll also will be on Friday. So basically, come a day early to the IETF and come to a conference all about video. And even better, submit a paper and talk about video at the conference. And I will say, the conference is operations oriented. So the theme there is operational discussions, operational technology, operational experiences, that kind of stuff. So there's a group I co-chair at the SVTA that has been working on networking and transport stuff, which is kind of related to the IETF things occasionally. One of the things we have been working on is a long-term analysis of Quick as a media transport for streaming. We've done a bunch of, one of the things we did is we created a reference test environment so that people who are Quick curious could go off and know what servers to, Quick versions and libraries to try, and how to set up a test environment so that they can do Quick experimentation on their own networks. We have also produced a white paper with a series of analysis results on Quick. I'll give you a bit of a heads up. We found that Quick was no worse than TCP. We also found it was really no better. Natively, it's what do you like to do? You can do it. Quick, we found, took a little bit more sometimes for the encryption work, not a lot more. It wasn't enough reason to say no to it. If you want to know more, read this paper. If you want to know more, come join the SVTA. You're probably already members. We have a lot of members. And you can participate in the readouts of the working group. And by the way, we've also been playing with congestion control algorithms because one of the cool things with Quick is that you can have user space congestion control algorithm selection. So we've done BBR and all the other good things that come with Quick. Well, I should say, this paper is downloadable. Just go to the svta.org website. It'll ask you to put it into a basket. It's free. You don't have to pay for it. Just click. The only reason we ask you to put it in a basket is we want to know who downloaded it so that we can follow up with you and say, hey, what do you think? So it's all free. So don't worry about that. And it's available. Just go to the website and download it, svta.org. All right. So the new working group, this was just spun up in January. The group literally started having phone calls mid-January, and the group met for the very first time at the SVTA meeting in Tucson, which ironically wasn't warm when we were there 2 weeks ago. But we spent about 8 hours starting to get into this. What is Edge? For those who have been watching the evolution of video, live sports is the next generation of video. In fact, I started characterizing video phases as 1.0 streaming was, can we do it at all? And when we saw things like Roku and other things like hit the marketplace, and Netflix started streaming about what, 2000, gosh, 8, 9, I forget now. That's sort of 1.0. The question 1.0 was, can you stream? Answer, yes, we can. We've been, for the last decade or a little bit more, working on streaming 2.0, which is, can you stream efficiently and at scale video on demand? So this is pre-recorded stuff. This is movies, this is TV shows that have been pre-recorded. It's stuff that you can pre-position on caches and you can distribute to manage the scale. That is largely what things like CD and I were very focused on. How do you do that efficiently? What are the protocols? The new frontier is live sports, low latency. It has some very distinct characteristics. First of all, it's not pre-recorded. It's happening live. So you don't have the opportunity to take a file and make 10,000 copies and spread it out around the world. It just doesn't exist yet. If you have been watching some of the news about video streaming, some applications have done really well. Other times at scale, some workflows have failed spectacularly in recent months. I'm not going to point any fingers at people. What we have learned from this, though, is that video live sports is not just reusing video on demand ecosystems. It has different characteristics, it has different problems. It has different scalability solutions. So what we have decided to do is create this Edge working group with the mission of tackling how to build a better workflow by scaling out for live versus buying really, really big pipes back to the stadium. Because buying a really, really big pipe, it does solve the problem, but it's also really expensive, and it's kind of dumb because if that stadium is only showing a really mega event this Saturday for the next 2 hours, and that pipe is going to remain unused for, say, the next 6 weeks, you're still spending money on that big pipe. It's just not economically viable to throw that as the solution. Instead, we think doing things out at the edge at scale is the right answer. So what are we building? We're building a hosting environment, and this doesn't mean we're not trying to build the cloud, we're not trying to build the fog, we're trying to keep it simple, stupid. So the thing is, if you have a hosted thing, this is the yellow thing. It's a thing that hosts things. Lightweight as possible. It's going to host the thing. That thing that we're going to host is a specialized cache that we don't care how the cache code inside works. All we know is that somebody has a specialized cache that's designed to deal with live. This could end up being SCI if you're there. It could be a mock relay. It could be HTTP2. It could be a CDN doing quick. It could be something that you have invented specially. We don't care. From the Edge working group, all we know is we want to be able to define a world which we can host that at the edge. Sounds simple, doesn't it? Just set up a server, put some code on it, and you're done. It's not that simple.
Do you want to take questions?
Yeah, the questions already, or should I do the next slide? Hi, Lenny. No, we're not going to use multicast.
How about TreeDN? It's only half multicast. And in fact, that server you mentioned, it could be a lot of things. Could it be an AMT relay?
So it could be. This could be part of TreeDN. You're right. This thing that's hosted. We're trying to remain really neutral in that there are other solutions. TreeDN solution, other forms of multicast solutions. Those are great, and where they work, use them. We're trying to add an additional option and choice for people building out architectures that they can choose from, but do it in a way that's both really simple and really lightweight so that it can evolve over time. And so really what we're going to do is we're going to define this. But when I said it's simple, well, you got all this. So we're not going to worry about how do you get the content fed into the cache. That is for the specialty caches operator designer to worry about. It could use CDNI. It could use something else. We don't care. All we are going to do is we're going to host it. But that comes with a lot of complexity, right? You have to give it IP addresses. You have to give it a control plane. You have to give it security. You have to probably do BGP and DNS. We have questions about if you bring along your own address space, who's going to sign that for the BGP stuff? This is hard questions. How are we going to gather telemetry? So if you imagine what the open caching work from SVTA did with CDNI. CDNI was a great protocol for exchanging between upstream and downstream caches. And then SVTA came along and built out the rest of the flushing things of how do you do logs, how do you do telemetry, how do you do all that other stuff you need to turn a protocol into a deployable solution. That's the next stage here. We're going to take this beastie. How do you host something? How do you build the other stuff around like logging and other stuff and policies and discovery and capabilities? Because one of the characteristics you're going to find when you do live sports is you don't need a lot of storage because you're not caching, gigabytes and hundreds of gigabytes of pre-recorded video. You're literally pulling the segments down from the live thing, and you're maybe keeping some of it around for trick play, and you may be offloading the other trick play stuff, which is the fast forward rewind type activity, replay stuff. You might defer that to an origin server, and you might defer that to your existing VOD infrastructure. You don't know. We don't know. We're going to build this thing to be able to host these hosted code things, and then build the upstream network, which is the stuff coming in from the core, and the down network obviously is the delivery to the client, and do it in a way that's generic enough so that people that come around with really clever hosted code cache things can put it in there. So are we talking to the mock people and other people that are interested in this space? That could be a mock relay. We're not going to judge. We're going to just enable it. So that is that. Any quick questions anybody wants on the edge stuff? If not, hit me up after this talk. I also wanted to highlight some other stuff the SVTA is in because I think this would be really of interest to the IETF crowd. We have a SVTA labs with a bunch of open source code. If you look up there, this is the stuff we're hosting today, like Dash.js, Shaka player stuff. This is all like practical code stuff that people at the IETF may want to use when you're playing with video. We got it. We got it, and it's open source. So come make use, please. You do not need to be an SVTA member to use any of this stuff. So if you want to know more, there's the website, svta.org. SVTA Labs is labs.svta.org. There's the URL for the segments conference if you want to come participate, if you know, as a participant, and if you want to present, we do have a CFP open right now. I'm Glenn Dean, I'm the me, and the other me is Sanjay Mishra from Verizon. We seem to have microphone problems in this room, do we not?
Yeah, no, the thing is that this was really slow.
Somebody was over
I wanted to
enthusiastic with
raise
the
it and then,
screws.
oops, it went away. Anyway, obviously, no hat, Eric Vink. On the slide, when you see all the labs, you put Squid and Nginx. As far as I know, Nginx is kind of stopped somewhere. So is it still hosted? I mean, it was a... You mean by doing this, you are hosting the repository in your...
I will be honest, I do not run the labs part. I know that these are all the stuff that we list on our labs website. If you go to the labs website, this is where I got these images. And so I can't talk to each individual project and what its status is. Sorry, Eric.
Okay. No.
I know a few things, but that I don't know.
Okay, because I'm a big fan of Nginx, right? So.
And for those who don't know, Nginx is a open source CDN cache software, widely used. Yeah, web server. Yeah, well, depends on what you want to serve, right? My world is video, man. There's no other content other than video.
Rajiv.
Do you have your hand up, Rajiv? Yeah. Oh, Rajiv, hi. Sorry.
Hey, everyone. Okay, so I also wanted to highlight one specific project at the SVTA that I think will have extremely great IETF tie-ins, which is the Common Error Codes project. It's starting off as a project which will bring in common error codes across all the different video players in the ecosystem, so that troubleshooting becomes a much simpler exercise today, especially if you're a large streaming platform vendor who's having to deal with a number of different devices and number of different players across their ecosystem. And of course, players is just the first step along this road. We eventually intend to have it cover the entire streaming ecosystem, so that when you have to go into logs from pretty much any part of your streaming workflow, you have one dictionary that you can go to understand and help debug when you see error messages.
Right. So a heads up, Mr. ADs, we might be bringing that work into the SVTA or the IETF ultimately. Once the SVTA's got done to find these error codes, we might be bringing them over here to publish as an RFC. These standardized player error codes for video applications.
That's the
plan. So heads up, there may be more mock work coming. So anyhow, any questions? Thank you, Rajiv. Any questions on the SVTA or anything like that? If you want to know more, let's see, I'm looking around the room. We got a pretty good collection of members already in the room. So hit Sanjay up or you can ask Tom here because BT just joined. They're a new member, so he can tell you about the new member experience. Anyways, thank you. I'm Glenn Dean.
Great, thank you. So with that, is there any other business? Then I think we can thank our note takers. So thanks to Dimitri, thanks to Chris remotely, and we will see you in Madrid. Thank you.
Well, you know what's interesting? I was noticing on the thing. Right now, I'm listed as a delegate inside when I go into the app, and Warren is listed as the technical advisor. So I don't know if there's I don't know if the AD needs to do some magic behind the scenes.
Well, you have to go. Nobody's not the case. I mean, this is
because you don't know where this is going to go. I could end up being the AD and not know it.
I don't normally, but that's a suggestion.
I put you as a delegate.